Now we have the topic the induced EMF in a metallic rod rotating in the uniform magnetic field. Let this is the rod of length L. This is the rod. This is the magnetic field. This is the point P and this is the point Q. This point Q is fixed and this rod is being rotated like this. In this way. This is being rotated with velocity v. It has the velocity v. So now we can have a small element here, a small element of length dl. Now this rod is of length l. This length l. This is the magnetic field v. Let a metallic rod of length L metallic rod PQ of length L is rotated with angular velocity omega perpendicular to uniform magnetic field. Magnetic field. Magnetic field B. Vertically inward, acting vertically inward of paper oblique board. This board, the end Q is fixed and P is rotating. So this is like this one. This is now rod and this is now being rotated like this one in this way. This metallic rod has the free electrons. As a result, there will be the Lorentz force. Lorentz force on these free electrons. So if we apply the this left hand rule, the magnetic field is like this one, and it is like this. Here I have this. So this positive charge will be on this side. It means that this point will be the positive charge and this will be a negative charge. the ends P of rod will be negative charge and fixed and Q is at positive charge. So this is now positive charge. This is positive charge and this is now negative charge. This is now positive and this is now negative. So there will be the induced EMF. So this will clarify in accordance with Lorentz force. Force F equal to Q into V cross V. So now we have induced EMF. EMF in element of length dA. Now this dE equal to, now this is BV into dA. We know that VDL, so in place of L we will write down this VL. Now this velocity linear velocity V is equal to L omega. So this we will write down this B omega L dl. This is equal to D. The induced EMF in whole of the rod. Whole of the rod. Induced EMF in whole rod PQ. This E is equal to integration 0 to L B omega L into dl. So this is now B omega and this integration will be now your L square upon 2. This is now 0 to L. So this is 1 by 2 B omega L square. This is not so much. And you are looking from here that this induced EMF is directly proportional to the magnetic field, angular velocity and the length of the conductor. As the induced EMF depends upon number 1, this E is proportional to this B, the magnetic field. E is proportional to B. And second, E is proportional to omega, the angular velocity. and third, this is proportional to L square, the length of the conductor. So if length is doubled, the EMF will be 4 times. If length is half, the EMF will be 1/4 of the initial value. So by increasing the length of the conductor, we can make the value of E to be higher or lower. Also we can have this omega. Now this omega is equal to 2 pi f. F the frequency. F. This is now frequency. Frequency of rotation. So we can have this induced EMF. So this E is equal to 1 by 2 B in omega. This is now 2 pi f into L square. So the 2 and 2 will cancel. So this is now your B f and this is now pi into L square. Pi into L square. So this is now B f A. This is now equal to E. Where A equal to pi L square. The area swept out by the rod. This is now pi L square. So you can see that this depends upon the frequency, or the either you say this angular velocity or the frequency. So larger the frequency, larger the induced EMF. So as the rod is rotated in the uniform magnetic field, then there is the induced EMF at the ends of the rod. If the magnetic field is vertically inward and rod is like this one, this is now magnetic field in this way, this is now rod, and this is being rotated in this direction. Then just to apply the Lenz's law, this Fleming's law, to find that which end will be positive and which end will be negative. So that this magnetic field is vertically inward, like this, and it is moving in this way. If I take it in this way, then this is now positive charge. So the fixed end will be at the positive voltage and the free end will be at negative voltage. So this gives the potential difference. That is the induced EMF in the rod. So this also we can have, if suppose there is a wheel rotating in the magnetic field. Wheel with spokes rotating in magnetic field. The center. Now this is like this one. This is suppose the wheel. This is now center, and this is now spokes. There are so many spokes are there, like this. This is now wheel. Then this ring. This will be at negative potential, and we are applying the magnetic field like this, in this way. If this is the situation, then this is being rotated like this, anti-clockwise. This is omega. This is being rotated about this axis. This is your anti-clockwise. So anti-clockwise we can show it. This is now in this. So this is being rotated, then this will be at positive potential and rim will be at negative potential. So center, positive charge, and rim, This is negative charge. This is negative charge. And if suppose this is moving clockwise, then this will be opposite of this one. The center will be at negative charge and rim will be at the positive charge. So this also depends upon the rotation of this wheel. If the spokes are increased or decreased, then there will be no induced EMF. And in this case, the induced EMF is equal to PFA. So induced EMF is equal to BFA. If the spokes are increased or decreased, there is no effect on induced EMF by changing the number of spokes. Number of spokes. In wheel. It means what? That whether this taken to be 4 spokes or 10 spokes, so this is independent of the number of spokes. Induced EMF is independent of number of spokes in wheel. So whether we are taking the number of spokes to be less or we are taking the more, then induced EMF is not affected by this one. So this remains always constant. So the wheel which is rotating in the magnetic field perpendicular to its plane, then there is always the induced EMF, but the positive and negative of the center and the ring will depend upon the speed and the direction of the magnetic field, and also this will be independent of the number of spokes in the wheel. So this is about the rod that is moving in this magnetic field. So thank you very much.